Welcome to another episode of Gâteau avec Sabrina. Happy Pie Day! Today's tutorial will teach you how to make your very own dies pie. It's very easy, fun, and will allow you to practice all the calculus that you love. I mean, what other recipe allows you to have fun and practice math? The recipe consists of only 8 steps, and at the end you will have a delicious pie and a cool equation to draw on it. What are we waiting for? Let's jump right to it! So here we have compiled the necessary ingredients. You need ginger, one in Y shape, one in an X shape. You will need milk, flour, an egg, some icing, and a pie filling of your choice. You will also need a wooden spoon, 1 cup, a large bowl for mixing, a measuring cup, and a round baking pan. Start with a bag of flour. Dump it into a large bowl. And you can take out as much flour as you want, or you can add in more flour. This way your flour will be nice and sifted. But don't only take out 1 cup because that wouldn't really make much of a difference. I know this is fun, but don't get too attached to the culinary domain. Take your denominator, set it equal to 0, and solve for x. This will give you the restrictions on your domain, which is x cannot equal to -1. Next, add in the roots. Make sure to never use the X-shaped roots because they are just ugly. It is crucial to use the Y-shaped ginger that is labeled with the Pie brand because they harvest organic ginger, and who would intercept you from eating healthy? To find the x-intercept, set the y equal to 0 and solve for x. In this case, we don't have an x-intercept. To find the y-intercept, set the x equal to 0 and solve for y. In our case, our y-intercept is 0 pi. Now determine the number of guests you'll be serving. If you have an even number of guests, divide the flour in half. If you have an odd number of guests, divide the flour again. Wait, aren't we just making 1 pie? Alright, so I guess it doesn't matter. Next, we're going to test for symmetry. If an equation is even, it should reflect over the y-axis. Our equation does not do that, therefore it's not even. If an equation is odd, it should reflect over the y and x-axis. And since our equation does not do that either, it is not odd. Therefore, our equation is neither odd nor even, which means it has no symmetry. Oh look, there's a vertical gap in the countertop. Be careful when you're cleaning up. It might fall into the gap of -1 and never stop falling. Good thing there aren't any horizontal gaps, or else it would be even harder to clean. Take the limit of f of x as x approaches to infinity or -infinity, and if it approaches a number, then you get a horizontal asymptote. Since we have a no-no here, take the greatest variable in the denominator and divide everything by this variable. Now retake the limit. Now take the limit as x approaches to -infinity. So since we have infinity and -infinity, we have no horizontal asymptote. For your vertical asymptote, take the limit as x approaches to your restriction, which in our case is -1. Since you get a number over 0, you now have to test the limit coming from the left and coming from the right. x approaches -1, y approaches -infinity and infinity. Therefore, we have a vertical asymptote. To find the intervals of increase and decrease, we want to take the function and find its derivative. Next, take your derivative and set it equal to 0 to solve for your critical points. Our critical points ended up being x equals -1 and x equals -1 plus or minus root 1 plus pi. Now pour milk into your measuring cup until you hit the -1 minus root 1 plus pi. Here you can see that I accidentally poured too much, so I had to decrease some of the milk. After mixing for 2 minutes, you can now add in -1 plus root 1 plus pi milliliters of milk. To find your intervals of increase and decrease, you want to draw a number line with your critical points on it. Test each interval by plugging a value between that interval in your derivative equation. If the value you get is positive, then it is increasing in that interval, and if your value is negative, then it is decreasing in that interval. After testing, we've discovered that our equation is increasing from -infinity to -1 minus root 1 plus pi, as well as -1 plus root 1 plus pi to infinity, and it is decreasing from -1 minus root 1 plus pi to -1, as well as -1 minus 1 plus root 1 plus pi. Now combine your dry ingredients to the liquids. Now you want to knead until desired consistency is achieved. Basically, until it kind of resembles pie crust. Now just mold the dough along the baking pan. Now you want to take your chosen pie filling to pour into your shell and struggle to open it. And make sure you pour in no more than a maximum of 6.07 tablespoons and no less than a minimum of 2.07 tablespoons to make sure that there is ample amount of flavor in your pie. Referring back to our intervals of increase and decrease, we can see that -1 minus root 1 plus pi is a local maximum with a y value of -6.07, and -1 plus root 1 plus pi is a local minimum with a y value of 2.07. out your dough for your pie covering. Place half of the pie shell in the concave up form and half of the pie shell in the concave down form. To find concavity and your points of inflection, you want to take the double derivative of your equation. Next, take your double derivative and set it equal to 0 to solve for your points of inflection. Since we cannot solve for x, there are no points of inflection. Next, draw a number line with your restriction on it and test the regions to find concavity. Our graph is concave down from negative infinity to negative 1 and concave up from negative 1 to infinity. Now cut the pie down the center to let it aerate. Now preheat your oven to pi degrees. Now place the pie in the oven and bake for 20 minutes. When it's ready, take it out and let it cool a bit. Now it's time to decorate our pie with our unique equation. Either use icing or carve your cool design onto your pie. Now using the information found in the previous steps, sketch your graph. Now draw your vertical asymptote, label your y-intercept, and your local maximum and local minimum, and sketch accordingly. What a great way to celebrate Pi Day!